Hi students, so today we will be solving a few very basic problems. Okay, those are very easy, but still I'd like to let you know about those before heading to the next set of new formulas. We will be doing some very fundamental problems, okay, just in case you still have a doubt. Okay, so mostly till now, whatever problems I have covered in integration up till now, those are enough for you to solve the very basic problems which are needed. There are many more basic problems as well, but then the formulas that I have done up till now, that I have taught to you up till now, problems, very basic problems or even medium level problems based on those formulas can be attempted by you. Even if you get stuck in the medium level problems, no issues, but I'll help you out. As soon as we go to the advanced problems, you will see that you are able to even implement your logic better in all of those questions. Okay, there are many more formulas. Actually, I have just shown you a fraction of those formulas. Before heading to the next video, which will be fully of formulas, I want you to pay attention to all of the problems that I'm going to be showing you. Even if they are easy, I want you to watch the video till the last minute. Okay, so the first problem here is that integration of tan x divided by sec x plus tan x into dx. Now whenever you have this kind of configuration, be very sure that you have to multiply and divide by the opposites. So say for example, here in the denominator I have sec x plus tan x, right? So in the denominator itself, I'll be multiplying sec x minus tan x, right? And as I have already told you before, that whenever you forcefully induce any term in a particular expression, it is important for you to also neutralize that, all right, so that the original expression remains the same. So since I forcefully induced a sec x minus tan x in the denominator, it is equally important for me to put it in the numerator as well, so that ultimately I'll only be left with a tan x divided by sec x plus tan x. Okay, so now that we have come here, we just have to simplify, and we will be getting tan x sec x minus tan square x divided by, this is the of the form of a plus b into a minus b, all right, which is nothing but a square minus b square. All right, so ultimately what we will be getting, sec square x minus tan square x, right? Now in the very basic trigonometric identity formulas, we know that 1 plus tan square x is nothing but sec square x. Okay, so based upon that, I can say that based upon that, I can say that sec square x minus tan square x, if I take this tan square x on the right hand side of this equation, then I'll be left with a 1 on the left hand side. So this sec square x minus tan square x can also be written as a 1, all right? And in the numerator, you can also see a tan square x, which I can replace by a sec square x minus 1. This is the prime equation that you have to remember, because based on this equation only you will be doing all the substitution in this particular question. So let me write it out for you in case you got a bit confused. This will become sec x tan x, and in place of tan square x, all right, we have a minus tan square x here, right? So what will I do here is that in brackets I will write sec square x minus 1. From here I get, right, sec square x, this 1 will come on the right hand side, so I'll get a sec square x minus 1, and on the left hand side I'll be left with a tan square x. All right, so ultimately I'll be getting this. Minus will remain outside of the bracket as it is, and then I'll be getting a minus of sec square x plus 1. If I multiply the minus sign with the respective expression in the bracket, this is what I get. So I'll be getting a minus sec square x plus 1. this into dx. All right. Now coming to the point that in the denominator I'll be having a 1, as I already told you, based on this formula. Okay, so now you can solve it by yourself, because you know that the integration of sec x tan x is nothing but what? It is sec x, right? The integration of sec square x is nothing but tan x, and the integration of 1 is nothing but x plus c. Is that clear? This is actually a very easy problem, still I decided to show you, because I think I have not solved a lot of problems based on multiplying and dividing with the opposite sign things. So this is why I decided to work on a couple of problems based on this. Now in the next question, we will be having, say, another similar type of a question which you can actually try by yourself, and I'll be doing here for you. Okay. So now similarly, as I told you, whenever you see any of these kinds of configurations, go with the exact manipulation that I taught you in the last problem. That is, in the denominator, you have to multiply by a cosec x plus cot x, and in the numerator you have to multiply by a cosec x plus cot x. All right, so ultimately what will you be getting? Now here similarly you have a minus b and a plus b format, so ultimately you will be left with a cot x cosec x plus cot square x divided by cosec square x minus cot square x. I hope you understand why, because a plus b and a minus b I already taught to you in the last question only. It's a square minus b square. So a is essentially cosec here and b is cot here. So with respect to that, I simply applied the formula. Okay, these are all the very primary level things. All right, but still I am explaining you in case you have forgotten. Okay, make sure that you don't forget it again. Okay, so now we have another very basic trigonometric identity of 1 plus cot square x is equals to cosec square x. Okay, 1 plus cot square x equals to cosec square x. Now here this is the prime formula which we will be using in this particular question in order to make certain very basic substitution. So what I'll be doing here is, in place of cot square x, I will replace by a cosec square x minus 1. If 1 goes on the right hand side, it becomes a minus 1. So cot square x equals to cosec square x minus 1 will be replaced in the place of cot square x. And in the denominator, essentially, I'll be getting a 1 based upon this formula. All of these manipulations have already been explained to you in the previous question. This is just a question with different terminologies, else everything is the same here. Okay, in the previous question we had a combination of tan and sec, and in this question you have a combination of cot and cosec. That is the only difference. Okay, so ultimately what I'll be getting here, 1 in the denominator, and in the numerator I'll just be replacing cot square x with a cosec square x minus 1, right? And then this into dx. Now tell me, what is the integration of cosec x cot x? It is nothing but minus cosec x. Okay. And what is the integration of cosec square x? It is nothing but minus cot x. Okay. And what is the integration of 1? It is x. So we get a minus cosec x minus cot x minus x plus c. Is that clear to you? It is again a very easy question, doesn't require this much of explanation. Having said that, I would want you to actually go through both of these questions, okay, in case you are still confused. It can be, all right. So now we will be heading towards the next problem, which is again a very basic problem. it is dx divided by sine square x into cos square x. Okay, so how to solve these kinds of problems? Now you can see that in the denominator you have a sine square x into cos square x, right? And in the numerator you have a 1. So can you just it's a very basic sort of perspective that you can place in this problem. That is, whenever you see this kind of problem, you can see that if you replace this 1 by a trigonometric identity, all right, then easily this problem will be solved. That is, in the place of 1, if I write sine squared x plus cos squared x, my expression is in terms of sine square and cos square only, right? So it becomes easier for us to solve the problem. These are pretty intuitive and you can do these by a little bit of common sense and logic, all right? This does not require a very heavy level of intelligence or something, okay? And now what you have to do is divide these things separately. So if I divide sine squared x divided by sine squared x into cos squared x, then I essentially, this sine squared x gets cancelled and I'm left with a 1 by cos squared x. Similarly, I'm left with a 1 by sine squared x. Integration, if you want, you can do that separately also. It's up to you. Now, here what will I be getting? I'll be getting 1 by cos can be written as a sec x. 1 by sine can be written as, sorry, there will be a dx. 1 by sine can be written as a cosec square x plus, yeah. Next, what is the integration of sec square x? It is nothing but tan x. What is the integration of cosec square x? It is nothing but minus of cot x. So tan x minus cot x plus c. So this was all about the 3 problems that I did show you. There are many difficult problems that we have actually attempted before. Still, I chose to show these kinds of problems because these are very basic and I don't want you to get stuck in these problems, because even though you will not directly be getting these problems in your examinations, not even in your board exams, there are very less chances of these questions directly being asked in your board exams. But the kind of questions that you will be getting in your boards as well as in your competitive examinations can be a direct application of these kinds of steps that I taught you. This is why I chose to actually get through these things in case you are still getting stuck, or in case you are not aware that these kinds of problems do exist, all right? So I chose to basically get through it. Now, in the next video, I'll be essentially, I have already done a lot of basic problems. Now I'll be doing a couple of formulas. All right, there are many formulas actually, but the next set of formulas I'll be doing in the next video itself, and I'll also be solving a lot of problems based on that formula as well. Now the assignment problems are still underway, okay? I'm not getting a lot of time to work on that, but I'm still trying to finish it, because the more you solve integration, the better it will be. Now there's one more thing that I'll keep repeating. I keep repeating it and I'm still repeating it now as well, that I want you students to basically not just copy paste the problems, okay? Now that you have solved a lot of problems, I think you have also understood my way of teaching and all. So because I think over 50 videos have already been uploaded, so I think you have now got a rough idea of how I teach and what I teach. So you have understood one thing, that I start a problem, I solve it, that's perfectly all right, but it is also important for you to solve that problem, try it at least first by yourself. Because see, if you get the trick by yourself, then it is very satisfying, right? Because ultimately at the end of the day, I'll not go for you and give the exam, right? It's you who is the aspirant here, who is the candidate here. You yourself have to go and appear for the examination, right? So me being able to solve the question is not of any credit, I want you students to be able to solve the question. And for that, say if I gave, while solving this problem, I gave this problem, then you should stop, pause the video, and then solve it by yourself, and then come back to the video, watch the full video, and then it's more complete. It feels more complete. Since I myself am a competitive exam aspirant, my mentor keeps telling me the same. To be able to solve the questions by yourself is very important. That essentially doesn't mean that you will still solve even if you cannot do it. You will sit with the problem, you will waste hours and hours, no. But my personal recommendation is, not just for now, but even in the future, if you take up engineering and all, you will be getting a lot of difficult problems to solve, right? Or you'll be appearing for many difficult examinations in the upcoming future. So my one big advice in this video for all of you guys is that whenever a question is being given to you, specifically when you're solving at home, or specifically if it's a competitive examination, or maybe you are solving an assignment of your college, all right, or of your school, then I would recommend you to spend some time, okay, say 15 minutes of time, not more than that. All right, don't spend 30, 40, 50 a whole day and then a whole week. That's not how it works. Just take 15 minutes of the time, and don't get distracted in these 15 minutes. So if you want, you can set a timer and then keep it at the side. 15 minutes you have to look at the problem, analyze the problem, try to solve it. If you can't, then go through the solution video. Okay, for now I'd say that see all of my solution videos, because class 11 and 12 is very fundamental and basic. So I would personally recommend you to not basically skip videos even in the future. Okay, don't skip videos. Don't have this kind of tendency that okay, I know everything, what's the point. Still, you watch it. If you want, you can fast forward it, but still it's highly recommended that you watch the entire video, okay? Because there are many important things that happened with me as well. I used to watch every video till end, okay? And this has also helped me a lot, because essentially students might think this is something that I already know, what's the point? But no, there are many things that you still don't know, and you will have basically, if you watch the entire video, you will have an edge over the other students who don't watch it. Remember that. All right, so what I said in this video is very, very important. Remember this advice for your lifetime, because now that if you take up engineering, it will be like 4 years you will be spending, 4 or 5 years, whatever. So it's highly recommended that you spend at least 15 minutes to your problems respectively. If you are able to do it earlier than that, well and good, congratulations for that. If you are not able to do it, 15 minutes of the time will be set, all right, in your timer, maybe in your mobile or clock, whatever you have beside you, and then you will solve your problems. If you think that you cannot solve it, after 15 minutes, see the solution video and then you can analyze, okay? This is the exact tip which I actually follow now for my competitive examination, and so I decided to share this with you in this particular video. Thank you so much. If you really like my video, then please don't forget to like, share, subscribe, and don't forget to hit the notification bell icon for more of such exciting content. Also, you are the guys who will be supporting my channel, so it's important for you, right, to keep updating me how well you are understanding what I'm teaching you, all right? And is it of any benefit to you? Of course it will be. That is why I'm teaching you, all right? So though I am getting a bit inconsistent nowadays, now I'll try to maintain my consistency by uploading videos every single day. I have a lot of pressure of work. This is why it is becoming a bit difficult, but still I'll try to club things up and basically be more consistent with my work. It's your future, I can understand, and thank you so much for supporting me. So now let's get down to the next video.